This is page 5 of the Chapter 6 notes. And what we're going to look at is binary compounds. What we're going to do is learn to write formulas from names and names from formulas. So let's start with some definitions. A binary compound has two different elements in the compound. And we're going to look at ionic compounds first. Ionic compounds are electrically neutral. And what that means is that the positive charges from the cations have to be exactly canceled by the charges from the anions. When we write formulas for binary ionic compounds, the cation metal is always written first, and the anion's name is going to end in IDE. So, for example, NaCl is sodium chloride. Now, let's take a look at what we mean by electronically neutral. Sodium, the symbol for that is Na. Because it's an alkali metal, its charge is just going to be +1. And then we've got chlorine. This forms chloride. Its charge is always -1. A positive and a negative exactly cancel each other, so the charges cancel. Let's take a look at iron 3 oxide. We've told you that it's iron 3. So the charge has to be 3+, okay? And we've told you that you have two irons. So we have Fe3+ and Fe3+. We have two cations. And then we've got 3 of these oxygens. And if you look on your periodic table, the entire oxygen family has a -2 charge. So what we have are 3 oxide anions, each with the charge of -2. So if we add these together from our irons, we have 6+, and then we'd add the -6 from all of our oxygen atoms, and we end up with 0. So iron 3 oxide is neutral because the positive cations are canceled by the negative anions. So let's look at some steps for writing binary ionic formulas from names. And let's scroll down the page before we do that so we get everything all on one page. Make sure we've got plenty of room here. Okay. So steps for writing binary ionic formulas from names. First, you're going to write down elements with charges. And we're going to do this first calcium bromide as an example. So our elements is we have calcium 2+, and we've got bromine with a 1-. We call it bromide because it's formed an anion. All right, next step, we're going to crisscross the absolute value of the charges. And I'm using that line there to mean absolute value, so I'll put one on the other side of charges. So we're going to crisscross the absolute values of the charges. And we're going to make them into the subscripts. So we're going to take the 2, and it's going to slide over here. And we're going to take the 1, and the 1's going to slide over here. And we end up with Ca1 Br2. However, we don't ever use 1, so we don't need to use ones. So we're just going to write it out as CaBr2. Let's put a little box around it so I know you're done with it. So that's the formula for calcium bromide. Now, the next step is sometimes you need to reduce the subscripts. So your next thing is reduce the subscripts if you can. And you have to reduce the subscripts if you can do it. So let's take a look at an example here. We're going to look at lead 4 sulfide. The symbol for lead is Pb. The IV means it has a charge of 4+. Sulfide is in the oxygen family, so it has to have a charge of 2-. We're going to crisscross the charges. So we crisscross the charges. And we end up with Pb for lead 2s4. However, we can divide both of these by 2, so we will. So this is going to become PbS2. And this is the correct formula here. Now let's try another one. Let's try magnesium nitride. And I want you to look on the periodic table and determine what it is. So let's say this is Mg, 2+, N, 3-. And you're going to crisscross, and you're going to make Mg3, N2. At this point, you should stop the tape. I am going to write in the rest of the answers, but you should see if you can get it on your own. So stop this thing right now while I write in the answers. Then you can open back up again and see if you got it right.